Quadratic inequalities. First, let's look at solving these algebraically. So for example, x squared minus 7x minus 30 is greater than 0. So first, make sure all terms are on one side with a 0 on the other. And I usually put all my terms on the left-hand side. It's usually simpler that way. I already have that case, so we already have x squared minus 7x minus 30 is greater than 0. Second step, let's factor the non-zero side. So in our case, the left-hand side. LHS stands for left-hand side. So we need numbers that multiply to negative 30 that add up to negative 7. And they are negative 10 and positive 3. So our left-hand side factors to x minus 10 times x plus 3. We're still looking for where that product is greater than 0. Third, let's find the zeros of the left-hand side. And we can do that using the zero product property. So I will set each of my factors equal to 0. X minus 10 equals 0, or x plus 3 equals 0. For the first equation, let's add 10 to both sides and we get x equals 10. For the second equation, we'll subtract 3 from both sides and get x equals negative 3. So my two zeros are negative 3 and 10. Fourth step, the zeros will divide the x-axis into intervals. And we will select test values in each of the intervals and determine the sign, whether it's positive or negative, of the left-hand side in each of the intervals. So I'm drawing a number line. Let's put our zeros at negative 3 and 10. Not being fancy there. And we can see, like, we could break the x-axis into 3 different intervals. And if I break it at those two zeros, I have 3 intervals. If I want to identify those intervals, I can use interval notation. So my leftmost interval is from negative infinity to negative 3. My middle interval is from negative 3 to 10. And my rightmost interval is from 10 to infinity. Now we're going to choose test values in each of these intervals. And we cannot use an endpoint, but we can use any number that's easy for us to use within the intervals. So a number that's between negative infinity and negative 5, between negative infinity and negative 3, I'm going to choose negative 5. Could have chosen negative 4, could choose negative 10. Any number that's in that interval will work. A number that's between negative 3 and 10, I'm going to choose 0. And a number that's between 10 and infinity, I'm going to choose 11. Again, any numbers in the intervals will work. Do not include the end value. So don't include 10, don't include negative 3. Now we're going to substitute these values into the left-hand side of our factored expression. So x minus 10 times x plus 3. So negative 5 minus 10 times negative 5 plus 3. I get negative 15 times negative 2, which is positive 30. So values in this interval will be positive. We're going to substitute 0 in, and I get 0 minus 10 times 0 plus 3. I get negative 10 times 3, which is negative 30. Values in this interval will be negative. Let's substitute in 11. 11 minus 10 times 11 plus 3. We have 1 times 14, which is 14. That's positive. So values in this interval will be positive. Step 5. The solution will include the intervals that satisfy the inequality. So I need to look at my original inequality statement. And I chose the factored form, that's fine. So I have x minus 10 times x plus 3 is greater than 0. So greater than 0 means we want values that are positive. So which intervals do we have positive values? We've got the first interval and the third interval. So our solution is from negative infinity to negative 3, union, that's a union symbol. Think about what you used in geometry. And then the interval from 10 to infinity. And that's our solution using interval notation. I could also write our solution using inequalities as x is less than negative 3 or x is greater than 10. And then just a reminder, if our inequality had been x minus 10 times x plus 3 is greater than or equal to 0, so including the zeros, then my solution would have been from negative infinity to negative 3 with the squared off bracket around the negative 3, union from 10 to infinity with the squared off bracket around the 10, because we would have been including negative 3 and 10. And similarly, if we were looking for the values that were less than 0, we would have been looking for the intervals where our values were negative. And that would have been the middle interval in this case. So those are the different possibilities we could have been considering. So that was solving a quadratic inequality algebraically. And showing the inequality form for the inclusion of the endpoints x is less than or equal to negative 3 or x is greater than or equal to 10. But also, let's go on and look at how to solve these inequalities graphically. So this was our original problem, x squared minus 7x minus 30 is greater than 0. We would still want to factor, and this time we would want to graph the inequality. It could be just a sketch. We don't have to have an exact graph, but we could also graph it in using the Desmos graphing calculator. So x squared minus 7x minus 30 is greater than 0, factors to numbers that multiply to negative 30 and add up to negative 7. We'd already found them to be negative 10 and positive 3. So now I could sketch the graph of this. We know our zeros are 10 and negative 3. We already found that algebraically when we looked at it on the previous two slides. So we know it's crossing the x-axis at those 2 points. We know that this parabola opens upward. So our vertex is somewhere below the x-axis, and I don't know exactly where it is. We could calculate it, but we don't need to. We don't know exactly where the vertex is, but we know it opens upward. And it crosses the x-axis at negative 3 and at 10. So then, if our inequality was greater than 0, like ours was, we want to find where this graph is above the x-axis. And if the inequality were less than 0, we would want to find where the graph is below the x-axis. But for ours, it's above the x-axis where I just shaded it more heavily. And so we've got this left part, which is x is less than negative 3, or the right part, which is x is greater than 10. And I could put that in interval notation as from negative infinity to negative 3, union from 10 to infinity. And that's how you would look at it graphically.